This problem asks us to find the derivative of a given function using the limit definition. And recall that the limit definition for the derivative is just the limit as h goes to 0 of this expression, which is called the difference quotient, f of x plus h minus f of x all over h. So I'm going to start by simply translating this expression given the function that we are working with. Okay. So f of x plus h, that tells me to take x plus h and plug it in to every instance of x. So f of x plus h here is 3 times x plus h minus x plus h squared. So there I've translated the f of x plus h, and I need to subtract the function that I'm working with. So I'll subtract that function, and I'm going to use parentheses to preserve distribution of this negative 1 here. And this entire expression is divided by h. The next step is to distribute everything out in the numerator. So here we have the limit as h approaches 0. Let's work this in a couple steps. I think first it's a good idea to expand this square, and that's going to be x squared plus 2xh plus h squared. And then in the next step, I'm going to worry about distributing coefficients over all these expressions. So this is the limit as h approaches 0, 3x plus 3h minus x squared minus 2xh minus h squared, distributing negative 1 over all those terms. And then in this case, distributing negative 1 again, negative 3x plus x squared all over h. Okay. And so we notice at this point, after we expand everything out, that the terms that do not have h's in them are going to cancel. And whenever we're taking the derivative of a polynomial, we expect that to happen. We expect all the terms without h's to cancel, which will allow us to factor an h out of the numerator. So after that step, I'm going to go ahead and simplify. And we get the limit as h approaches 0, 3x, negative 3x, so those cancel, 3h. Negative x squared, positive x squared, that cancels. So I'm left with a 3h minus 2xh minus h squared all over h. So I notice that I can factor h out of the numerator, and we're left with 3 minus 2x minus h all over h. And now I can cancel the factor h in the numerator and the factor h in the denominator. And this is the whole point of this process, is to be able to cancel out these h's, because once we do that, we can plug 0 in for h. We will no longer be dividing by that 0, so we can just plug 0 in. So let's simplify this. We get the limit as h approaches 0, 3 minus 2x minus h. And so notice there's no longer a problem with plugging 0 in for h. We are simply left with 3 minus 2x. And so this is f prime of x.